Now let us start with the right atrium. You remember that the sinus venosus had right and left horns. 3 veins to the right, 3 veins to the left. The right atrium will swallow them entirely. The left horn will regress and form for me the coronary sinus. Because you remember the blood shunted from the left to the right. The right will be the inferior vena cava. So as the right atrium is following the sinus venosus, it will swallow part of the inferior vena cava, and opening of the inferior vena cava will be directly to the right atrium. This is exactly what is shown in this picture. These are the 2 horns. These after they fused and the blood shunted from left to right, and this is after the atrium swallowed them, leaving for me the coronary sinus to the side, or originally the left horn of the sinus venosus, and this is the inferior vena cava and the right atrium swallowing it. This is another picture explaining it. This would be the left, then the coronary sinus, this is the inferior vena cava later on. Now a very important thing to explain is as the atria, both the left and right, swallowed whatever they had, they regressed. In other words, the cells that were originally from the pulmonary veins or from the sinus venosus will be now part of the atrium itself, left and right respectively. These cells were smooth, okay? But the original cells of the atrium, they were trabeculated, they weren't organized. Now, as they were swallowed, the trabeculated cell regressed, and I had the smooth part around it, okay? The smooth part then is what will form for me the adult atrium, and is now, we all know, that is formed from the sinus venosus or from the pulmonary vein. What about the trabeculated part or the original part of the atrium? It will be an auricle, or what we see in the adult heart as the left and right auricle. As simple as that. The story of the atrium is done. Now let us talk about the story of the ventricle. The same concept. I will have cells that are clustering, but instead of going downward, they will going up because they want to reach the endocardial cushion. And their story is similar and easier actually. Cells will start growing, going upward, forming for me the interventricular septum. And we don't have premium and secundum here, we have one, which is the interventricular septum. It will grow and grow and grow, and it will not reach the endocardial cushion, so it doesn't tear. It will stop. As simple as that. Now, do I have the shunt? Yes. Focus in here, please. Blood came from the inferior vena cava. From the right went to the left. To the left ventricle. But some of the blood went to the right ventricle. Okay? This blood will now go through the interventricular foramen to the left ventricle, and from here it will go to the body. Later on, I will tell you that in here I will have the aorta, and here I will have the pulmonary trunk. Okay? But we'll explain them in the upcoming slides. What will happen next is that as this foramen is formed, it will need to be closed because the 2 ventricles must be separated completely in adult. What will happen is that cells from the endocardial cushion will start growing and closing it. As if the endocardial cushion hates the atrium and doesn't help it, and loves the ventricle and help it. So eventually, I will have 2 parts of the interventricular foramen. A membranous part, which was from the endocardial cushion, and the muscular part, which is from the floor of the ventricle itself. Okay? And we are done from the story. Now let us talk about the development of cardiac valves. It's a very easy story, as simple as you see the connection or the atrioventricular canal that remain here, okay? Between the now left atrium and left ventricle, right ventricle and right atrium, this canal, cells will start growing from 3 sides, or clustering from these 3 sides and approaching each other and form for me the valve. As simple as that, and the story is done. What about the valves of the aorta and pulmonary trunk? I did not explain how they form yet, but keep this in your mind, the same concept will apply. Cells will start swallowing from 3 areas and form for me the valve. So the 4 valves of the heart are formed from 3 swallowings. Later on, I know there will be 2 and 3, sorry, 2 doors and 3 doors, but even the 2 are drawn from 3, but the picture will be shown easier, but keep this in your mind, 3 swellings. Now let us continue about primordial observation. We did explain it. Now let us talk about the bulbus cordis and truncus arteriosus. In order to do so, I will remind you that the bulbus cordis is initially a one tube. The truncus arteriosus is just part of the bulbus cordis. Okay? Now imagine I have a tube, and in the middle of that tube, I will form the partition. The exact same story that happened in the atrioventricular canal. So this is the tube, cells will grow and close it to give me 2 canals. But the trick is in here is that there will be a folding or switching. Adilillah, can you please come and help me in the switching? Imagine, please hold Adilillah from this side. Imagine that this is the tube from here and going here. So this is the upper side, this is the lower side, this is the partition that form. What will happen next is that I will have a switch of a 180 degree. Now let me just draw some colors on it. Imagine that this right color, of course I'm just giving an example, it's not the exact, that the upper portion, the blue portion is for the pulmonary trunk, and the red portion is for the aorta, okay? And the same is for Abdulilah's side, the aorta down and pulmonary trunk is on top. Okay? Let us see what will happen. 180 degree. Keep in your mind that we are saying in this part that this is the pulmonary trunk and this is the aorta. 180 degree. I will just switch it. Now notice what happened. This area, the upper area for Abdulillah is the pulmonary trunk, but for me, now it is the aorta. What about the aorta of Abdulillah? It was down, it is down. For me, it is up. Now for pulmonary trunk, it is down for me and up for Abdulillah. So the aorta and pulmonary trunk switched in their position. Please focus in here. Thank you, Abdulillah, for the help. Please focus in here. This is the partition, okay? Later on, as I'm circling it, I will have a division in the middle. So the aorta will be to the side and the pulmonary trunk will be to the other side. Imagine if I took the section of the example in the middle. Later on, they will change inside. Notice please, this is the aorta. It's switched and became in this side, and for the pulmonary trunk, it switched and became to the other side. I hope the concept is really clear now. So 180 degree, and the bulbus cordis with the truncus arteriosus will form for me the aorta and pulmonary trunk. As simple as that. You can notice them switching. This is the aorta switching or circling around the pulmonary trunk and then going down. This is the pulmonary trunk going around the aorta. And with this, we form the heart. Now let us just give a preview of the conducting system of the heart. The heart, if you remember from the previous lecture, we said it was contracting cardiogenically, or from the contractions were from the heart itself. Later on, I need these contractions to be regulated. So cells from the neural crest or neural crest cells will then go into the heart. From where they will enter the heart, they will enter it as the heart is swallowing the sinus venosus. So at the beginning, I will have, when the sinus venosus is swallowed, I will have this SA node or sinoatrial node in the right atrium, because the right atrium is the one that aids the sinus venosus, and that is where the neural crest cells will come from. So the SA node will be in the right atrium. Now what about the AV node and its bundle? They just grow in the atrial septum and they go down into the ventricle. Very important and a very important concept in here is that cells or the connective tissue outside the heart will now start going into the heart. Why is that very important? Because these cells will form for me the cardiac skeleton. This cardiac skeleton will separate the atrium from the ventricle. And why is that very important? Or what do I mean by separation? I mean electrically. In other words, the electrical signals from the atria will not go into the ventricle except through the AV node. The importance of that lies in atrial fibrillation. If these electrical signals were able to go into the ventricle, then I will have ventricular fibrillation and the patient will die. Thank Allah that does not happen. Atrial fibrillation patient, they live, unlike the ventricular fibrillation. So atrial fibrillation will not go into the ventricles because of the cardiac skeleton. And the cardiac skeleton is formed because of the epicardium or the connective tissue going into the heart. So let us review the entire story simply. Atrial ball dividing and having a connection between the foramen ovale and the foramen secundum. Ventricle ball growing, a septum is growing, and then the endocardial cushion will close it. Well, we separated them. We did talk about the heart valves being from 3 swallowings. We are done from that. What about the bulbus cordis? The bulbus cordis, as we said, form a partition in the middle of it and circle in 180 degree, with the aorta being to the left ventricle, pulmonary trunk to the right ventricle, and they will circle and go around. The pulmonary trunk into the lungs, and the aorta into the body. As simple as that. And we already explained the conducting system. Thank you for listening. In the next lecture, inshallah, we'll be explaining the arterial system.